Angles of elevation and depression are useful for solving worded practical problems using right-angled triangles. So the angle of elevation and depression is defined as the angle between the horizontal and the line of sight to the object. An angle of elevation is measured upwards from the horizontal. So you can see in that diagram there, this is the horizontal. This is where the person would be looking if they look straight ahead, and then they have to look up in order to be able to see the sun in the sky. So the angle between the horizontal and where they have to look to see that object above them is our angle of elevation. If we look at an angle of depression, that's measured downwards from the horizontal. So once again, we have our person here who is the horizontal. This is where they would be looking if they were looking straight ahead. And then in order to see an ant on the ground, they have to look down at this angle of depression. Couple of examples to help us with this. The first one is we're asked to find the angle of depression from the top of a building 50 metres high to a point on the ground that's 80 metres from the base of the building. Now the diagram wouldn't be given in this question, you would have to draw it for yourself. So the first thing I would do is put my building in my diagram, and I would put my point on the ground that's 80 metres away, and we know that the building is 50 metres tall. Because we're looking for an angle of depression from the top of the building, then we're taking our angle of depression from this point here. So the angle of depression is defined as from the horizontal. So if we look straight out from that point, this is our horizontal, and then we have to go down to see that point on the ground over here. So this is the angle of depression. A really common mistake in this unit of work is that students try and put the angle of depression in here. It must always be from the horizontal down to the object you're looking at that is below you. Now, this angle of depression here is not actually part of my right angle triangle. There are a number of ways to solve this. You can actually create a right angle triangle out here so that your angle is part of it. You could actually determine this interior angle in here using the fact that you know this is a 90-degree angle. And so once you found this one, you could then determine what this angle of depression is. Or the way I've chosen to work this question is I've chosen to use our Z rule. So we know that our horizontal here and our ground are parallel, and therefore you can see that we have a Z here. And with our Z rule, we know that that means this angle here and this angle here are equal. So I have added the theta down to here. That now gives me a right angle triangle where I'm trying to find this angle because I know it's the same as my angle of depression up here. I have 50 metres along this side and 80 metres here. So I'm going to label my sides. 50 metres is my opposite side, 80 metres is my adjacent, and therefore I'm going to use my tan ratio. Tan theta is opposite over adjacent. Substituting my values in, it becomes tan theta is 50 over 80 because 50 is my opposite and 80 is my adjacent. And we know from last lesson that in order to find our angle theta, we need to move our tan to the other side of the equation using inverse tan. When I put that on my calculator, I get theta equals 32 degrees. It's important that I finish that question with a worded statement because the question didn't ask me to find theta, it asked me to find the angle of depression. Question 2, Sally is standing 10 metres from the base of a tree. To see the top of the tree, Sally has to look at an angle of elevation of 48 degrees. Determine the height of the tree, and the question's asking us to ignore Sally's height. So this is the diagram that I've drawn. Ignoring her height, we have that this is the horizontal, and we've got our tree. We know that she's standing 10 metres from the base of the tree, and that the angle of elevation she has to look up at in order to see the top of the tree is 48 metres. Now it tells us to ignore her height, so this distance here we're just not worrying about at all. I have my opposite side here, my adjacent side here. This would be a right angle triangle given that the tree is growing vertically. Opposite and adjacent means, once again, I'm going to use tan. Substitute my values in. Tan of 48 degrees equals x over 10. This time I'm not trying to find an angle, but I'm trying to find a side. We did work on that a few lessons ago. So if I want to solve this equation for x here, then I want to move the 10 to the other side. It's currently a divide by 10, so when I move it to the other side, it's going to become a times by 10. This goes into our calculator, and I'm getting that the tree is 11.11 metres high, and once again I'm finishing that off with a worded statement for my worded question. Here are the questions that you are going to complete. They're also listed on OneNote. My advice for here would be to leave the extension questions until after you finish these worksheet questions, because these extension questions are quite difficult.